Hello everyone, I'm Cynthia. Previously, we introduced the enthalpy difference lab. Today, let's explore another important test lab in the energy efficiency testing industry, the Heat Balance Calorimeter Room. As mentioned in earlier episodes, the Heat Balance Calorimeter Room provides more scientific and precise test results and is generally used for benchmark calibration. So, in this episode, let's talk about why the Heat Balance Calorimeter Room is famous for being scientific and precise, and where its methodology is more rigorous compared to the enthalpy difference lab. The accurate name for the Heat Balance Calorimeter Room should be Balanced Ambient Room Calorimeter. As the name suggests, it's essentially a calorimetric instrument built from rooms. Its measurement principles is that if the temperature and humidity in the room remain constant, it means the room is neither gaining nor losing heat. This principle is like a balance scale, where temperature and humidity act as the pointer. Suppose there is an air conditioner running in the room, but we don't know its cooling capacity. How can we measure it? We can balance this cooling capacity by adding balance heat when the temperature and humidity pointer remain stable. We can conclude that the cooling capacity equals the heat we added as a balance weight. Hence, it's commonly called the Heat Balance Calorimeter Room. The heat weight is generally achieved by measuring the total electrical power input into the room. The principle is that all electrical energy converts into various forms of energy, mechanical, heat, light, etc., which ultimately dissipate as heat within the room, forming the weight that counteracts the cooling capacity of the unit under test. Now, let's look at the structure of the Heat Balance Calorimeter Room. Like the enthalpy difference lab, the Heat Balance Calorimeter Room is also divided into two chambers, an indoor side and an outdoor side. These simulate the indoor air environment and the outdoor air environment, respectively, acting as the inner chamber of the room calorimeter. However, what makes it more complex than the enthalpy difference lab is that both the indoor and outdoor sides of the Heat Balance Calorimeter Room have an additional outer chamber. In other words, the Heat Balance Calorimeter Room consists of four independently separate rooms: the indoor side chamber, the indoor side outer chamber, the outdoor side chamber, and the outdoor side outer chamber. Why are there two extra rooms? This relates to the term balanced ambient. For a calorimeter, the better the adiabatic performance, the more accurate the test results. If there is heat exchange between the room and the outside world, it means the heat weight will not precisely equal the cooling capacity, leading to measurement errors. Therefore, to improve measurement accuracy, energy is wrapped in an outer chamber around the main test chamber. An air handling unit regulates the temperature of this outer chamber to always match the temperature of the inner chamber. Since heat transfer is proportional to temperature difference, a zero temperature difference means zero heat transfer, effectively eliminating the interference of heat leakage on the measurement results. Thus, the heat added to the inner chamber can be entirely attributed to measuring the air conditioner's cooling capacity. As you can see in the diagram, the inner chamber is also raised, with every surface situated in a controlled zero temperature difference environment, minimizing heat leakage to the greatest extent. In summary, the testing method of Heat Balance Calorimeter Room is entirely based on the fundamental principles of thermodynamics, compared to the enthalpy difference lab's method of calculating cooling capacity by multiplying enthalpy difference by airflow. The heat balance method is more scientifically rigorous in principle. Using electrical parameters to measure heat involves fewer sources of error, yielding more reliable test results. Due to its accuracy and reliability, the Heat Balance Calorimeter Room serves as a standard reference, widely used for benchmark calibration and arbitration tests. This is why testing departments and institutions heavily rely on it. That concludes our basic introduction to the Heat Balance Calorimeter Room for this episode. In the next episode, I'll take you to explore the energy consumption aspects of Heat Balance Calorimeter Rooms and how GZ Lens Company applies energy-saving technologies to them. Finally, if you have any requirements for purchasing an enthalpy difference lab or a Heat Balance Calorimeter Room, or if you are interested in energy-saving technologies, please feel free to contact us.